In this final video, we are going to look at two-slit interference with light in two different simulations. This simulation starts by looking at water, but we want to jump to light. So this is meant to be a lamp. It's currently producing waves of red light. We want to put in two slits. So here they are, and we're going to move the slits closer to the source and see what we get. The easiest way to view this is by clicking on Show Screen, and then I like to also look at the intensity graph. We can see here that it is bright at the edges and darker in the center, which corresponds to what you see here. Now watch what happens if I take and make the barrier in the middle bigger, and therefore the slit's smaller. Now, surprisingly, you have a bright spot right behind the barrier. You have dark wings, and then maybe you can tell it would get bright again out here on the edge. In order to see that effect well, it's easier to flip it over from red to blue, so let's look there. And let's increase the amplitude just to make it brighter. Again, you have this lovely bright spot directly behind the barrier, a null, so constructive interference at the center, a dark spot, and then it gets bright again on the edge. This is a two-slit interference pattern. The second simulation ignores this part of it and just looks at what would this graph look like. So here it is. Here's the bright spot in the center. Oop, let's get it onto double slit mode. You get a bright spot in the center, then it goes down, and you get a bright spot again, and then it goes down, get a bright spot again. Right. Currently this is set for a blue wavelength. Watch what happens when I move it to red. The entire pattern gets broader. Everything about it gets broader. Let's set it in the middle, and instead we're going to increase the slit separation. Increasing the slit separation makes the fringes narrower, and decreasing it makes it broader. You can also play with the slit width. That has an effect on the fringes as well. It doesn't change, say, these little fringes, but it does affect kind of the overall pattern. If the slits go really narrow, then you get this kind of broad peak with all these little dots underneath it. And if the slits get very broad, you kind of end up with only one bright spot and very little in the wings. The last question you're asked to consider is, what role does diffraction, the bending of light, play in the observed pattern? To look at diffraction, I want to look at single slit mode. And now it's really obvious what happens when you make the slit width narrower versus broader. If I flip between single slit and double slit, can you see that the single slit pattern is kind of overarching the double slit?